Hello viewers, welcome yet again to another math lesson for the upper basic level. Now this is targeting the grade 9, but it can be useful also to other grades as well. Now today we are looking at the relation between the sides and angles of a triangle. So the relation between the sides of a triangle and its angles, okay? So we're looking at the relation between the sides of a triangle and also its angles. Now, says the triangle inequality. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. Now we all know that a triangle is just a three-sided figure, okay? Every triangle has three sides. It has 1, 2, 3. So what this is saying, that if you should add any two sides of that triangle, that sum has to be greater than the remaining side. So if I was to call this as side A, and I call this as side B, I call this side B, and this as side C, if I should add length of side A and the length of side B, my sum should be greater than the length of side C. Now likewise, if I should add A and C, my sum should be greater than the length of B. And then, again, if I add B and C, my sum has to be greater than the length of A. That is what this thing is saying. So what does this mean? If you take the three sides of a triangle and add them in pairs, you know, pairs mean in twos, all right? That means you add two sides at a time. The sum is greater than and not equal to the third side. That's just an emphasis there, okay, that if you take any two sides of the triangle, you add them up, your sum has to be greater than the third side. It cannot be equal to it, it cannot be more than it. It can be less than it, it cannot be equal to it, it has to be more. Now, if that is not true, then it is not possible to construct a triangle with the given side lengths. So if you go ahead and add any two sides of the triangle, and you get an answer which is either equal to the third side or less than the third side, so then we conclude from there that those three sides cannot form a triangle, okay? Now we can do some investigation here, and let's see what works. Suppose we are given some sides here, a triangle of sides length 5 centimeters, or let's just say 5 units, 3 units, and 10 units, okay? So if you are given those three sides, we want to know whether those lengths can form a triangle. Length of 5 units, 3 units, and 10 units. What do? We take any two sides, we add them up, and see whether the answer we get is going to be greater than the third side. If it works for all three of them, then it's okay. So let's take first 5 plus 3. Now, if you add 5 plus 3, what do you get? You get 8. Now, if you get 8, is 8, if I say 8 greater than 10, is that really true? Is 8 greater than or is 8 more than 10? That's definitely not true. So this is not greater. So immediately one doesn't work. There's no need to go through the rest, because all three are supposed to work at the same time. So if one doesn't work, nothing works then, okay? So the fact that we have added 5 and 3, and the sum we get is less than our third side, so we can conclude from there that these three lengths, 5, 3, and 10, cannot form a triangle, okay? Now let's try another 3 sides. Let's say we are given 6 units, 4 units, and then 10 units. We want to know whether those three lengths can form a triangle. Again, go ahead the same way. Add any two pairs and see if you get an answer always greater than the third side. Like if we take 6 and 4 and you add them up, what you get is 6 plus 4 should give us 10. Now, if you get 10, can we say 10 is greater than 10? Obviously, we know that 10 is actually equal to 10, not greater. So this also is not correct. Again, what did we say? If one doesn't work, nothing works. Okay? So just from there, we can conclude that 6, 4, and 10 cannot form a triangle. Okay? Now let's look at the third one. We have 7, 5, and 10. We want to know whether this will form a triangle. Okay? Again, let's investigate. First, we take any two sides. Let's say 7 and 5. If you add them up, what do you get? 7 plus 5 should give us 12. And 12 greater than 10. Is that true? Is 12 greater than 10? Obviously it is. So this is correct, because 12 is definitely greater than 10. But now that one has worked, to be really so, we must go through all the other possibilities. All right? Because remember, all of them should work. So if we have added two of the sides and we get an answer which is greater than the third side, now let's add two other different sides and see if this still holds. So we have added 7 and 5, and we got 12. And 12 was greater than our third side, which was 10. So now let's see if we switch this now. Let's add, let's say, the 5 and the 10, and see if we will get an answer greater than our remaining side, the 7. If you add 5 plus 10, you get what? That should give us 15. Is 15 greater than 7? It is, obviously. So that also holds. So the two we have tried have worked, but then all three should work. We have used the 5 and the 7, it's okay. Now we have used the 5 and the 10, it works. There's still one more pair left. We need to add the 7 to the 10 and see if we get an answer which is greater than the third side, in that case 5. So let's see. If we now add the 7 and the 10, will that be greater than our third side, which is 5 in this case now? 7 plus 10 should give us 17. And 17, is it greater than 5? Yes, 17 is definitely greater than 5. So all three work. So we can conclude that 7, 5, and 10 can form a triangle. Those sides can be used to construct a triangle. So you can see, when one didn't work, we did not bother to test the rest. But when one worked, we have to go ahead now and test for all the rest, just to confirm, okay? Now we can actually try this practically. Now, if you can take a ruler and a pencil, we can try to see practically how this works, okay? Let's prove that 5, 3, and 10 cannot form a triangle, okay? Because it didn't work from our own calculation here. Then also let's see that 7, 5, and 10 actually works, okay? Now let's see if we can do that. Let's take up our ruler. You need a ruler and a pencil for this, not a protractor. Okay, so that's our ruler we have here. We checked the size that we used. That didn't work. We used 5, 3, and was it 10? Yes. Now let's see practically that these three lengths cannot form a triangle, okay? We need to use our ruler and measure a line segment of 5 centimeters, 3 centimeters also, and then 10 centimeters, and see if we can combine those to form a triangle with no overlapping, all right? So let's first measure the 3 or the 5 centimeters. I need to measure 5 centimeters exactly on my ruler. Okay. Now that is my 5 centimeters, okay? I need another length, which is exactly 3 centimeters. 3 would be here, okay? That's 3 centimeters. And still I need the longest side, that is the 10 centimeters. 10 centimeters would be somewhere here, yes. Good. So now we have got our 3 lines. Now let's see if we can fix this together and form a triangle with no overlapping. Okay? I tried to do it, let's say. Bring this one here. Fix it to this line here. And I want to rotate here. Okay? Now let's see if I can fix the longer one also. There you go. Now what do you observe? When you fix them together, there's this length excess. There's this one overlapping, and that shouldn't happen. All of them should have fixed exactly into a triangle, like this. They should have all fixed like this. No side should have been extended. But here you can clearly see that there is an extension here. No matter how hard you try, you will always have an extension. So this clearly tells you that these 3, 5, 3, and 10 cannot form a triangle. Okay? Now let's try the ones that really worked. And what worked was, we used 5, we used 7, and then we used 10. Now let's see if this worked. This didn't work. So let's try this other one. We still need our ruler. Okay. Let's measure 5 centimeters. This is 5. Okay. Then, next I need to measure 7 centimeters. 7 is right here. That is 7. And then I need the 10. 10 would be from this point here right down to here. That is 10. Fine. So now I run the ruler again. I need to find a way to fix these 3 lines together and form a triangle with no overlaps. So let's see if that works. Observe. You are able to form a perfect triangle, all right? And there's no overlap anywhere. They fit exactly into a triangle, okay? So that's just a demonstration which you can try at home to see that really 5, 7, and 10, those lengths can give a triangle because they fit exactly and there's no overlapping anywhere, okay? That was just a demonstration. So now we can continue. Just determine if sides of length 5 centimeters, 8 centimeters, and 12 centimeters can form a triangle. Now we are going to go through this using the calculation because now we have shown practically how we can actually do this using our ruler and pencil. Now we test all 3 pairs to see if the sum is greater. When you take 5 and 8 together and you add them up, you get 13. And 13 is definitely greater than 12. So that works. Okay? Now when you now take 5 and 12 and you add them up, you get 17. And 17 is definitely greater than 8. That's the remaining side. That's also work. Then if you now take up 8 and 12 and then you add them up, you get 20. And 20 is also definitely greater than 5. So again, all 3 pairs are correct. You add any 2 sides there, the sum we are having is greater than the third side. So these 3 lengths can definitely form a triangle, okay? So you can conclude, yes, it is possible to construct a triangle with sides of length 5 centimeters, 8 centimeters, and 12 centimeters. So now we look at this other example. We determine if the sides of length 3 centimeters, 4 centimeters, and 9 centimeters can form a triangle. Again, we go through the same process. We take any 2 sides, we add them up, and see if our answer is greater than the third side. Here we say test all 3 pairs to see if the sum is greater. Now if you take 3 and 4 and you add them up, you get 7. But is 7 greater than 9? That's not so. 7 is definitely not greater than 9. So that doesn't work. And actually you could have stopped here because 1 doesn't work. We know it doesn't work. Because I said here all 3 have to work. So if 1 is out, then there's no need. But just to test and see that this is good to understand this, because now you are seeing that 3 plus 9 is 12, and that is greater than 4. And then you add 4 plus 9, you get 13, and that is also greater than 3. If you are not mindful, you may conclude that this size can form a triangle. But then, don't forget, the first one didn't work. And all 3 are supposed to work, okay? So, no, it is not possible to construct a triangle with 3 sides of length, or with sides of length 3 centimeters, 4 centimeters, and 9 centimeters. I must keep emphasizing that all 3 have to work. Even if one doesn't work, then they cannot form a triangle. So in this case here, although 2 of the scenarios worked, but one of them did not work. So therefore, these 3 sides cannot form a triangle. Now let's try this. Determine if triangles can be formed with the following side lengths. Okay? Now this is something you can be doing along with me, okay? You look at 4 centimeters, 7 centimeters, and 10 centimeters. We try all the 3 possibilities and see if they all work. That's something you should be okay with now, all right? So let's see. Work with me. Let's take the first 2 sides. That is 4 and 7, and see whether if we add them up, our sum will be greater than the third side, which is 10. Okay? So let's see. 4 plus 7, will that be greater than 10? If you add this up, 4 plus 7 is going to give us 11. Is 11 greater than 10? That is true. 11 is definitely greater than 10. So this one works. Correct. But we have to try all 3. Okay? Now we have used 4 and 7, and it works. Now let's say 4 and the 10 now, whether if you add them up, our sum will be greater than the 7. That's the third side in that case. So if we take the 4 plus the 10, will that be greater than the 7? Okay? 4 plus 4, you add that up, that should give us 14. Is 14 greater than 7?
You said 4 plus 4. 4 plus 10.
I said 4 plus?
4.
I said 4 plus 4. Okay. So we test the 4 with the 10 and see if you add them up. I'm going to have to take this out. Okay. So we have seen that actually the 4 and the 7, if you add them up, the sum you get is greater than the third side. So that's a check, it works. Now let's try another 2 sides, 2 different sides again. This time, let's take the 4 and the 10 and see whether if you add them up, you will get a sum greater than the third side in this case, which is 7. So if we take the 4, you add it to the 10, will you get a number greater than the third side here, which is 7? And if you add 4 and 10, that will give us 14. Is 14 greater than 7? Yes, it is. So this also works. So 2 scenarios have worked, but there's one more to check, all right? We need to confirm all 3. Now we take the 7 and the 10 and see whether if you add the 7 and the 10, you will get a sum greater than the 4. So 7 and 10, will you get an answer greater than 4 rather? Now if you add 7 and 10, that should give us 17. Is 17 greater than 4? 17 is clearly greater than 4. So therefore, all 3 scenarios worked. So we can conclude therefore that 4 centimeters, 7 centimeters, and 10 centimeters can actually form a triangle, okay? And we can go through the same process for all of these examples, okay? I'm going to go through 2 of them with you again, and then I'll expect you to be able to go through the 4th one on your own, okay? So let's see. Number 1 is correct. It can form a triangle. Now let's go to number 2. At number 2, we have 24, 20 millimeters, and 30 millimeters, okay? Let's take up the first 2, the 24 and the 20. If you add them up, that will be 24 plus 20. If you add that up, will you get an answer greater than 30? And obviously, 24 plus 20, that's going to give us 44. Is 44 greater than 30? Yes. So the first one works, okay? Let's try the other set. Now we have used 24 and 20. Next, I want to use 24 and 30 and see if I add them, whether I will get a sum greater than the 20. So if I do that, 24 added to 30, I'm looking for an answer greater than 20. Now if you add 24 and 30, that should give you 54. Is 54 greater than 20? Yes, 54 is definitely greater than 20. So this also is a check, all right? We still have one more pair to try. We need to add the remaining pair, that is 20 and 30, and see if you get a sum greater than 24. And if you do that, 24, no, 20 and 30, you add them up, will you get a sum greater than 24? 20 and 30, if you add them up, that should give you 50. Is 50 greater than 24? Yes, it is. So these 3 sides will definitely form a triangle, okay, because all 3 scenarios work out correctly. Now, I'm going to try out the last one with you, and like I said, the 4th one, I will leave it with you to determine.
That one, can you use the line statement?
Okay, so now we're looking at 7 centimeters, 9 centimeters, and 16 centimeters. Let's see. Let's add up the first 2 and see if you get an answer greater than the 3rd side. So we take up 7 centimeters plus the 9. Will that be greater than 16? Now if you add 7 plus 9, that should give us 16. Is 16 greater than 16? No, 16 is definitely not greater than 16, because 16 is actually equal to 16. But what did we say? Our sum must be greater than the 3rd side. It cannot be less, it cannot be equal to. So obviously this 16 is actually equal to 16, so this is not working. And remember, we said that all 3 conditions should work. So if one doesn't work, there's no need to bother to go through the rest, because whatever you get in the end, still this one have already disqualified this from working. So there's no need to go through everything else, all right? So once one scenario doesn't work out, we know that's out. So these numbers, 7 centimeters, 9 centimeters, and 16 centimeters, cannot definitely form a triangle. You can conclude based on that, all right? Now you can go ahead, try to compare this. 9 centimeters, 13 centimeters, and 24 centimeters. Try to determine if they will form a triangle. Remember, it's a simple rule. If you add any 2 sides, your sum should be greater than the 3rd sides. Any 2 sides you add, okay? That you can test for. Now, based on what we have just done in all this while, what generalizations can we make about given segment lengths and whether or not they form a triangle? I don't know if you observe any pattern in what we have done so far to determine whether the three given sides can form a triangle. What did you observe? Okay. What we can conclude from what we have done so far is that you add up the two smaller side lengths to see if their sum is bigger than the longest side. All right? That's an easy one. If you add the two smaller sides, if you add them up and see if your answer is greater than the longest side. If they are, then the triangle can be formed. And that makes sense. Because if you take any three numbers, and one is bigger than the other two, if the two smaller angles add up to a number greater than the bigger number, obviously, if you add the bigger number to any other smaller number, you get a sum greater than the other smaller number. That's too many words. Let's say I take 3. I take, let's say, 5. Okay? And I take 7. If you take this as your test case, if you add 3 and 5, you get 8. All right? And 8 is definitely greater than 7, and 7 here is the longest side. So based on that, I can conclude that this can form a triangle. Why? Because I know now, if I add the longest side 7 and 5, I will definitely get a sum greater than 3. Likewise, if I add the same longest side 7 to this shorter side 3, I will get a sum greater than 5. So that's a shortcut to knowing. You add the two smaller sides. If the sum they give you is greater than the longest side, then those three lengths can definitely give you a triangle. Okay? That should be a shortcut you can use. What we do is, we just add up the two smaller sides and see if their sum is bigger than the longest side. If that is the case, then we can conclude from there that those three lengths can give a triangle. Like, you look at this example here. If you look at 5 centimeters, 8 centimeters, and 12 centimeters, now the longest side there is the 12 centimeters, and the smaller ones are the 5 centimeters and the 8 centimeters. Now, when you add the smaller lengths, that is the 5 centimeters and the 8 centimeters, that gives you 13 centimeters. And 13 centimeters is definitely greater than 12. So the sum of the two shorter sides is greater than the longest side. So from there we can conclude that these three lengths can form a triangle. Likewise, if we look at 3 centimeters, 4 centimeters, and 9 centimeters, we try the same test and see. The longest side there is the 9 centimeters, and the shorter sides is 3 centimeters and the 4 centimeters. If you add up the two shorter sides, that is 3 and 4, you get 7. But is 7 greater than 9? No, 7 is not greater than 9. So therefore, these three side lengths, that's 3 centimeters, 4 centimeters, and 9 centimeters, cannot form a triangle. Okay? Because the sum of the two shorter sides is less than the longest side. So this cannot form a triangle. Now here is something you should be able to know now. Determine if segments of length 5 millimeters, 14 millimeters, and 19 millimeters can form a triangle. Now you should be able to do this on your work, because now we know the trick. Okay, we know how we can prove that this can form a triangle, and actually we now have the shortcut. All right? If you recall just the previous slide, we spoke about the shortcut. Remember? That would be, you add the two shorter sides. If their sum is greater than the longest side rather, then you are good to go. They can form a triangle. Otherwise, no, they cannot form. So here, what is the longest side here? The longest side is 19 millimeters. What are the shorter sides? They are 5 millimeter and 14 millimeters. So now, if you add up those two, the 5 millimeters and the 14 millimeters, will we get an answer greater than the 19 millimeters? Has to be greater. Obviously, if you add 5 and 14, that should give you, yeah, that's 19 millimeters here. Not meter, millimeter, yeah? Now, this is also in millimeters, have to be the same units, of course. Now, if you add up the 5 millimeters and the 14 millimeters, that should give you 19 millimeters. But is that greater than 19 millimeters? Is 19 greater than 19? That's not true. 19 is definitely not greater than 19. Actually, 19 is equal to 19. And our sum should not be equal to. So, just based on that, we can conclude that these three lengths, that's 5 millimeters, 14 millimeters, and 19 millimeters, cannot form a triangle. Okay? Again, let's go through the same process. Oh. Because 19 is not greater than 19, so you can conclude that this doesn't form a triangle. So what's the answer? No. The answer is no, that these three lengths cannot form a triangle. So our answer here would be no. Now go ahead and try this and see what you get. See if you can determine whether 9 centimeters, 6 centimeters rather, 9 centimeters and 14 centimeters, whether they can form a triangle. Okay? We know the shortcut, so that shouldn't take us time. First, what's the longest side? The longest side is 14 centimeters. So that should be less than the sum of the shorter sides. Okay? And the shorter sides are 6 centimeters and 9 centimeters. Now, if we add 6 centimeters and 9 centimeters correctly, we should get 15 centimeters. Now, is that greater than 14 centimeters? Yes, obviously, 15 is greater than 14. So, we can conclude that yes, these three lengths can form a triangle. So, this would be a yes. It's a triangle. Okay? Now, let's keep going ahead. We still have three lengths again, 5 centimeters, 13 centimeters, and 21 centimeters. Can they form a triangle? First, what is the longest side? The longest side is 21 centimeters. Will that be less than the sum of the two shorter sides? And the shorter sides are 5 centimeters and 13 centimeters. Now, if you add that up, 5 and 13, that should give you 18 centimeters. Is that greater than 21 centimeters? Since they are the same unit, 18 is not greater than 21. It's actually less. So these three lengths cannot form a triangle. Okay? I'm going to skip this. I'll let you know the process now. So again, you can quickly go through this and see and determine whether these three lengths can give you a triangle. 5 centimeters, 5 centimeters, and 9 centimeters. What's the trick? Take the two shorter sides, add them up, and see if your answer is greater than the longest side. Here, our longest side being the 9 centimeters. So if you take that up, 9 centimeters, will it be less than the sum of the two shorter sides? Okay? That is the 5 centimeters and the other 5 centimeters. If you add that up, you get 10 centimeters. Will that be greater than 9 centimeters? Yes, it is. 10 centimeters is definitely greater than 9 centimeters. Okay? So this will form a triangle, and we can say yes. Answer here would be yes. Okay? And with that, we come to the end of today's lesson. I hope you have learned something from it. Till we meet again. Goodbye.